The bonus exercise for this project is to produce an image that looks like this. So what on earth are we looking at here? Well, if you're feeling particularly imaginative, you can try pausing the video and just, free associating what you see here. It almost looks to me like there's a man running, like here's the arm and here's his other arm and these are the two legs. Here's his head and he's running. I don't know, this is like smoke or something. Anyway, what you're actually looking at is the result of an algorithm that involves drawing a line and changing the direction of the line based on prime numbers. So let me explain the algorithm, and then we'll just switch to Python and start coding it up. Okay, so here's how it works. So what you do to create this image is you find all of the prime numbers between 2 and n, where n is a parameter of the analysis that you get to pick. So for this image, I picked n equals 100,000. So find all of the prime numbers up to 100,000. Of course, you can pick any number you like. And then what you want to do is loop over all of those prime numbers. So in a loop over the prime numbers, you compute the distance from each prime number to the previous prime number. So for example, the first two prime numbers are 2 and 3. So the distance between 3 and 2 is 1. So that's the distance here. Okay, and then you travel that distance, and you start off by traveling north. So you start going up. So you travel north by 1 unit, and then you rotate the direction by 90 degrees clockwise. So that means when you first travel up north, then the next prime, you're going to travel that distance, or the distance from that prime to the previous one, to the east, so to the right, and then south, and then to the west. And then you go back to traveling north. So just to make sure this algorithm is clear, I'm going to explain the first few movements. All right, so we start off at the origin with a prime number of 2. And then the next prime number is 3. Now the distance between 3 and 2 is 1. So we travel 1, and then we go, we travel that distance north. So just up on the y-axis. And then we find the next prime number, which is 5. And the distance between 5 and 3 is 2. So we have to travel 2 units. Here we traveled 1 unit. Now we're traveling 2 units. But we change direction. We rotate 90 degrees clockwise. So that means the next prime number, so the next line is going to be like this. Now, the next prime number after 5 is 7, and the distance between 7 and 5 is 2, and we're already traveling east, so now we have to change directions and travel south. And then the next prime number is 11, and that's 4 units, so we travel this way. And now the next prime number, which I guess would be 17, that's a distance of 6, and then we go back to north. So I'm not drawing this anymore, but 17, the next prime number, would be a line that goes up here like this, 6 units. All right, so I hope that's clear. What you should do is 2 things. First of all, you want to just implement this algorithm and draw an image that looks like this. Just a static image. Don't worry about the working with the animation. First, just create this image. And then once you have this, you have all of the numbers stored, all the coordinates to draw this interesting looking pattern. Then you switch to an animation, and making an animation should be pretty straightforward because you have all the code from previous videos. Essentially, you're just going to loop through like this and make this image. Now, there's one thing I would like to warn you about is that if you try to draw this image one individual piece of this line at a time, you might run out of memory. You might run into some memory problems because this is going to be a huge animation. So you might want to, think of some clever way to get around the problem of running out of memory because each individual frame is going to be so large. Okay, so switch to Python. You can do this totally on your own or look through the helper file. And now I'm going to switch to Python and show you my solution. Okay, so we need to test for prime numbers. Now, you can write your own function to determine whether a number is a prime number, but I'm going to import from the library simpy. There's a function called isPrime. So let's just have a look at this function. So isPrime, and let's input a number that we know is a prime number. So how about 3? Okay, and then we get true, and how about 4? And then we get false. Okay, so what we want to do here is basically loop over a bunch of numbers and figure out which numbers give a result of true and which numbers give a result of false. So let's see if we can input a vector in here. It's always a good thing to try. So I'll write numpy.arange, and let's go up to 10. So what I hope, would be pretty convenient if the output that we get out of this would be, like 0 would be false, and then false true for 2, true for 3, false for 4, and so on. Let's see if that happens. Uh-oh, we get an error. It says only size 1 arrays can be converted to Python. Okay, so basically the problem is that it just doesn't allow us to input an array of numbers. So we can only input one number at a time. No problem. We still have two ways of solving this. We can write a for loop. So we can say for I in range 100,000. And then we can test each number. That's totally fine if you do this in a for loop. I'm going to do this with list comprehension. Let me define n. So 100, like this. Now I'm going to do this with list comprehension, and just as a bit of a refresher on list comprehensions. So let's say for I in range n, if is prime I. Okay, so again, there's a lot of, when you do list comprehension stuff, it's a lot of, it's very dense. So the main thing is here, this is our for loop here. So for I in range n, this part is pretty simple. And then we have the next piece of that gets evaluated within each element of this for loop. And that is this, if is prime. So this is either true or false. And then this is the result here. So if this is true, then we output I, which is our number here, our integer. And if this is false, then nothing happens, and we go to the next iteration, the next value of I. Okay, so I will call this variable PS, not for PostScript, but for primes. So let's see what this number ends up being. Okay, so we got a whole list of numbers here, and let me go all the way up to the top. So, and yeah, it's pretty easy to confirm. I see I made a mistake in the slides. I said the next prime number after 11 was 17. So it's actually 13. But yeah, we can see these are all the prime numbers, and curious to see how many there are. So I'm just going to hover the mouse over here. So there are 9,592 prime numbers between 0 and 100,000. Okay, so now let's write this algorithm that I showed in the pseudocode in these slides. This is probably the trickiest part of this bonus video. This is the most difficult part. So I'm going to start by initializing the matrix. This is going to be the matrix of XY coordinates. So I'll set this to be zeros, and it's going to be length, so the number of primes by 2. Now, just as a reminder, this is an easy mistake to make. When you use numpy.zeros, it's going to say data type not understood. So numpy.zeros is expecting the first input to be all of the sizes, not like this. So it's a little confusing, because if you do some random function, random.rand, then this actually is the correct notation. But with zeros, you have to give all of the dimensions of the matrix in the first input. So we can use a tuple like that. All right, so now the way that I'm going to set this up is in a for loop. So for I in range of the number of primes. Now, we're going to need to access the difference or compute the distance between the ith prime and the I minus 1th prime. So that means that we actually need to, so it's going to be something like this. We're going to compute a distance variable. It's going to be the ith prime minus the I minus 1th prime, like this. Now this is going to, this is actually not going to give us an error if we do this, but the range here is going to start at 0. So I is going to start at 0. So therefore this is going to be 0 minus 1, which is minus 1, which is actually the last element of this array. So that means that the first distance is going to be 2 minus 100,000, whatever is the prime number that's closest to 100,000. So therefore, we actually want to start at 1. We want to start counting at 1 so that we start with the distance between the second prime and the first prime. Okay, I hope that makes sense. All right, and now what we want to do is update the XY coordinates. So how do we do this? Well, let's think about this. So we want, let's just think about the first iteration of this loop. We want to start by going north. So how do we change the X and Y coordinates if we want to go north? Well, what north really means is that we are going up the Y-axis and we are not moving at all on the X-axis. So the X-axis value doesn't change and the Y-axis value has to increment by distance, by this variable dist. Okay, so that would be something like this. So we'll say XY, the ith row, and both columns, that gets updated to be something new. And what is that new thing? Well, the X coordinate, so we have specified the new X coordinate and the new Y coordinate. The new X coordinate is just the previous X coordinate. So I minus 1, and the X coordinate is 0. Okay, so the X value doesn't change from one iteration to the next, but the Y value does change. So first of all, let's change this to a 1, so we're working with Y, and that increments by the distance. So there we go. So this is the new XY coordinates are equal to the previous XY, the previous X coordinate, and the previous Y coordinate plus this distance. Okay, now if we just leave the code like this, that's always going to go north. It's always going to go up, and the resulting image is just going to be a straight line going all the way up the y-axis. Not super interesting. Okay, so what I'm going to do, the way that I solve this, is to specify a direction variable. So let's create a new variable. This is going to be our direction variable, and I'm going to initialize it to be 0. And the idea is that this is going to loop through. It's going to go 0 and then 1 and 2 and 3, and then it's going to go back to 0 and so on like this. And each time this direction variable is equal to 0, it means we go north. When it's 1, we go east. When it's 2, we go south, and so on. Okay, so let's see. So if direction equals 0, then we do this. And if, so otherwise, if direction equals 1, then what do we want to do? Well, let's start by copying and pasting this line. So we still want to update by the previous X and the previous Y, except now if the direction is 1, that means we're cycling after 0, so we go 90 degrees clockwise, which means we go east. And east means we do not change the Y-axis, and we add the distance to the X-axis. So I'm just going to move this dist over here, right? So I hope that makes sense. So now we are keeping the Y coordinate the same as the previous prime, and the X coordinate stays itself plus the distance that we traveled since the previous prime. All right, I'm sure you can see where this is going. If direction equals 2, and then let's see what we want to do here. So now we want to go south. So going south means the X-axis doesn't change, or the X value doesn't change, and the Y value changes, but instead of going positive, which would be for north, it goes negative. So we go down the Y-axis. And then finally, if direction equals 3, then you can see the pattern here. So the Y-axis coordinate stays the same, X changes, but we go negative. So this is taking us west to the left. All right, so now, so this is actually mostly finished now. The thing is that this direction variable needs to update, right? So it's never changing now. So we need to, let's see, we need to update the direction variable. So direction, now you could do something like this, equals itself plus 1. And then, this is going to go, this will go above 3, of course. So we could say if direction equals 4, then set the direction to be equal to 0. So this is totally fine. This is a perfectly valid way to implement this. I'm going to show you a different way. And let's see, I'll just create this dummy variable d, and that's going to be numpy.a range, let's go up to 4. So just to show you what this is, so this is just our numbers, 0, 1, 2, 3. Okay, so what I'm going to do is write d plus 1 modulus 4. Now this is not going to do anything terribly interesting, except it's going to increment each value by 1. So notice d started off as being 0, 1, 2, 3, and now it's 1, 2, 3, 0. So now let's set this up to, I don't know, how about 14? So now we can see that the numbers in d are going from 0 up to 13, but this little computation here, this little algorithm, so d plus 1 mod 4, is giving us each of those numbers plus 1, and then it cycles back to 0. Okay, so therefore, I'm going to say direction equals direction plus 1 modulus 4. Okay, so let's see. So let's run all this code, and it doesn't give us any errors, and that's already a good sign. Okay, and then let's just have a look at xy just to make sure that we actually get stuff. You know, it's not all zeros, for example, or nans. So we do get valid numbers everywhere. So we start at the origin, and then who knows what's happening in here. We will have to visualize it, but there's certainly, you know, it's increasing somehow. All right, so I'm going to mean center this. So if we look at the average, so numpy.mean of xy axis equals 0, so the average x value is 270 and the average y value is 310. So what I want to do is mean center this so that the image is centered at the origin of the graph. Now there's no particular mandatory reason why that has to be, but I don't know, I think it's a little bit nicer. So I'm going to use broadcasting here to subtract the mean of xy axis equals 0, like this. So you remember broadcasting. This is something I introduced in part 1. So basically, this is a 2-element vector. This is a matrix. And we compute the average across all the x values and all the y values. So across the axis equals 0, so the first axis. And that's going to subtract that average, which is this vector here, from every row of the matrix xy. Okay, so run this again and compute the mean again, and that's going to be 0 or something very, very close to 0. All right, now we still don't know whether we've done the right thing. So let's make an image. This is going to be a static image. I will say plt.plot. So we want to plot the x coordinates, so that's 0, by the y coordinates. And let's make this a black line. And yeah, I think I'll just show it like this. And there we go. So there's a couple things, you know, we could change. The axis isn't square and so on, but this certainly confirms that we've done the right thing. We see this little guy running at top speed, and he's running so fast his head is splitting apart or something. I don't know what this is. All right, so let's go on to the animations. So you remember that to use matplotlib.animation, what we need to do is set up 3 things. So we need a function for drawing each frame, and then we need to set up the image, and then we need to create the animation. So creating the animation was the thing that we did. Ani equals animation.func and animation, and yeah, then setting up the image. This one was, let's see, I'll do this. So fig x equals subplots, and then make it a nice healthy size. So make it a big square, and then let's see, we need a plot handle, and that's going to be x.plot. And then this is the same thing that I wrote above. So xy of all rows and the first column, and then we have x, y, and all rows and the second column. Make it a black line. And then let's see, I'll turn the axis off because we don't actually care about the numbers here. We just want to look at the patterns. And I'm also going to make sure that we have a square axis, so equal aspect ratio for both the x-axis and the y-axis. Now this is something that I showed you how to do in part 1. It was probably the section about visualization. So ax.set aspect, so that's how we set the aspect ratio. And then what we do, there's a little trick that we use for setting the aspect ratio, which is to divide by, so we just invert whatever is the current axis ratio. So 1 divided by get data ratio. Okay, so let's see. I'm going to just comment this out, and just to make sure that all of this code is correct. Okay, so that code looks good. It still produces the image, and we get this figure object, and we get also this handle to the line that we can then adapt. Okay, so let's see. So now we need to write the function. I will call that a-frame, because that's what I always call it. And let's see, what do we want to do? Well, it's actually a little bit simpler than some of the previous videos because we don't really need to compute anything. You know, all of the data are already computed. So the only thing we need to do is to update the plot. So ph.set xdata and xy. And now what we want to set the data to is everything from the beginning. So all the rows, all the prime numbers from the beginning up to I. So this is going to be :I and then 0. So this says everything from the beginning up to I. Now in the beginning, I is going to be equal to 0. So this is, you know, just going to evaluate to 0, 0. But as I increases, as I gets larger, this is going to give us more and more data. Okay, so that's the X data. And then we have the Y data. We update the Y data. That's exactly the same format. We want all the same rows, of course, but now we want the Y coordinate. Okay, and then we have to return ph. All right, so that is pretty straightforward. Now we need to specify this animation here. So the first input is the figure instance. The second input is the function a-frame, and then we are going to input the input into, so the third input into func animation is going to be our input variable into this function here, which here I call I. So you can see that's just going to be integers that go from 0 all the way up to the length of xy. So to range, and then that's going to go length of xy. Okay, now it turns out that if you just run it like this ends up being a huge animation because of the number of high resolution frames that Python needs to store all at the same time in one object. So you're gonna get some, you might get some warnings or some error messages here. So what I'm going to do to resolve this is say, give me numbers that range from 0 to length of xy, which is 9,500, whatever that number was, and then skip. So I don't want all of them. I want to skip according to some number. Yeah. So let's see, you know, we could arbitrarily set this to be 100. So that would mean that we are not going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We skip by 100. So it's going to be 0, 200, 300, 400, and so on. Okay, now I'm just going to soft code that. I'm going to set this to be skip frame equals, and let's set it to be 100. So now here I can write skip frame. All right, so let's see. I've written quite some code. Hopefully I've done everything correctly, and then we should be able to see this animation. All right, let's see what we got here. Okay, so let's run this, and it looks pretty cool. I'm going to increase the speed a little bit, and you can see this thing building up. It's like snaking around, and it starts all over again. I'm going to set this to be reflect. So now it's like winding down backwards. I think this looks pretty neat. Now, if you like, you can try changing a couple things. You can change the skip frame, see how that affects it. You can try changing this algorithm. You know, there's no particular reason why it needs to go north and then east and then south and then west. So you can try changing this algorithm. Maybe you want to have the algorithm be a little bit biased. So let's say every time you go north, you don't go by the distance, you go by half the distance. And maybe, you know, when you go south, you go by a third of the distance instead. So there's all kinds of interesting things you can do. Another option would be to say, when direction equals 0, you go the full distance to the north and you go a little bit to the east. So let's say plus dist divided by, I don't know, divided by 6. So now you're not going totally north, you're going a little bit north by northeast, let's say. Maybe, okay, this is going to be better. Here we're going to go minus, so now we're going to go north by northwest.